Hello, once again, ladies and gentlemen. We are here right now to go over the review for our quiz 11, which is on equations, And so you're going to see a whole bunch of equations. Remember that equations have equal signs. And our goal is always the same whenever we're dealing with equations. Our goal is to isolate the variable. In fact, I'm going to write that down. Our goal is always to isolate the variable. Isolate the variable. However, as you can see here, number one, this is not so much about solving the equation, but rather matching the equation with a given situation. Well, in that case, guys, let us pay attention to the operation. What are we doing to the variable? What is happening? We can see that we are adding 2. So x plus 2 equals to 10. So let's see what situation has number one, addition, that we're adding 2 to some variable, something that can vary, and we get 10. So letter A, there are 10 students on the soccer team. Okay. The team has an additional 2 students as managers. How many students are there in total in the soccer team and the managers? Now, are we adding 2 and 10 here? No. And so that's clearly not the answer. Next one. Riker bought a sandwich and chips for $10. Okay. The chips cost $2. How much was the sandwich? Okay, so he bought them both for $10. The chips are $2. So obviously I have to combine the sandwich and the chips. The chips are $2. So that seems to make sense because this could be the chips and this could be the sandwich, and together they give me 10. Okay, so I'm gonna put a check mark. That seems to make sense. That seems to make sense. Let us continue. Sophia ran for 10 minutes. Tom ran 2 more minutes than Sophia. How many minutes did Tom run? All right, so 10 minutes, Tom ran 2 more. So are we adding 2 and 10 or no, or that doesn't make sense. No. And then Giselle ate 2 more fries and her friend who ate 10 fries. Again, here they seem to want to combine 10 and 2. Are we adding 10 and 2? No. So ladies and gentlemen, the only one that makes sense is B. So that would be the answer. So make sure that you just go down the line. Make sure and that the situation matches the equation. All right, so enough of that. Let's go to number 2. Number 2, we're actually solving this equation. Notice that it says what makes the value of y, or which value of y makes the equation true. In other words, what does y have to be for this to be a true equation, a true thing? What do we multiply 2/3 by with y? So one of these numbers here to equal 4. Now, we could replace y with each of these numbers and work it out and see which of those gives you 4. Or, ladies and gentlemen, we can simply solve the equation. Let us solve the equation. And again, to solve equations, we have these 3 things to remember. Number 1, our goal is always the same. It is to isolate the variable, meaning we want the variable to be all by itself on one side of the equations. How do I do that? Well, we isolate variables, ladies and gentlemen, by using the opposite operation. So in a second, we're going to focus on the variable. We're going to find it. And then we're going to ask ourselves, what is currently happening to it? Are we adding, subtracting, multiplying, or dividing? Whatever it is that is happening to it, we're going to do the exact opposite. If we're multiplying by a number times the variable, then we're going to divide by that same number. If we're adding or subtracting, then we're going to do the opposite. Okay. And finally, ladies and gentlemen, remember that whatever you do to isolate the variable, you must do the same thing to the other. So we must do the same thing to both sides. So let me go ahead and rewrite it. So we have 2/3. It's a weird looking 2. So we have 2/3 y, and we together they equal 4. Okay, so where's the variable? So from what I can see, the variable is here on the left side of the equation. Remember, guys, that the equation sign is basically like a wall that divides the left side of the equation from the right side of the equation. And the variable is here on the left side of the equation. Now, ask yourself, is the variable isolated currently? Is it totally by itself? No, if it was, it would just be y equals something. All right, so why not? Because we are currently multiplying y times 2/3. So I need to isolate the variable. I need to get rid of that multiplication by 2/3. And how, ladies and gentlemen, how can I get rid of multiplying? Well, the only way to get rid of multiplying is to do the opposite of multiplication, which is to divide. So as we are multiplying by 2/3, I'm going to just make a little note here that says, okay, well, let's divide by 2/3. Remember that when you multiply by something and then you turn around and divide by this same something, that equals 1, and 1 times y is just y. So y is now isolated. It is by itself. However, whatever you do to one side, you must do to the other. Make sure that you do the same thing to both sides, which means that I need to divide 4 by 2/3. Lucky for us, we know how to divide. We know how to divide fractions. We need to remember this is 4/1. And to divide fractions, I must remember to keep, change, and flip. Keep, change, flip. And when I do that, we keep the 4/1. We change the division to multiplication, and then we flip to 2/3 into 3/2. Now we're viewing the same problem, but now from a multiplication perspective. All right, and then to multiply fractions, remember we do numerator times numerator, denominator times denominator. 4 times 3 is 12, and 1 times 2 is 2, and then I can simplify. 12 divided by 2 is equal to 6. Now, is that one of my answer choices? Yes, but am I certain that it's correct? You can be. You can always check your answer, ladies and gentlemen, by substituting the variable with that actual number. In this case, the number 6, and you can work it out. 6 times 2 is 12. 12 divided by 3 is indeed equal to 4. So yes, it checks out. The answer has to be 6. Y has to be equal to 6. Now, I know that I took a lot of time in this problem. The rest will not take as long, but you're going to notice I'm going to follow the same process. We're going to isolate the variable. How? Using the opposite operation. And whatever we do to one side, we will do to the other. So I'm going to leave those up there, actually. Isolate the variable. How? Using the opposite operation. And then whatever you do to one side, you must do to the other. So let us look at number 3. Notice that the instructions are quite similar. It says determine the value of S. That makes the equation true. In other words, solve the equation. How do I solve equations? We isolate them variables. All right, so let's go ahead and begin by rewriting the equation. We have 56.27 is equal to the variable S minus 33.21. All right, so ladies and gentlemen, we can see that the variable is here on the right side of the equation. So I'm going to ignore the left side for now. And focusing on the right side, is the variable isolated? No. Why not? Because we are currently subtracting, sorry about that, by 33.21. Well, how do I isolate the variable? We isolate the variable by doing the opposite operation of what is happening. So the opposite of subtracting 33.21 is to add 33.21. And by doing so, by definition, these will cancel out. That's 0 and 0. S minus 0 is just S. So S is now isolated. However, remember that whatever you do to one side, you must do to the other. All right, we must do to both sides. In this case, why am I adding 33.21? Well, to isolate the variable. And you can do that as long as you do it to the other side as well. So let's go ahead and add this side plus 33.21. And by doing so, that's going to give me, remember, we line up the decimal. So 7 plus 1 is 8. 4, bring the decimal down. 9, 6 plus 3 is 9, and 5 plus 3 is 8. Yes. So S has to be equal to 89.48. Easy enough. Easy enough. Moving on to the next one. Even quicker still. Number 4, what makes the value, what value of D makes the equation true? Again, isolate the variable. Isolate the variable. When in doubt, isolate the variable when you're dealing with equations. So we have -7 is equal to 12 plus D. All right, let's isolate the variable. Again, the variable is here on the right side. Here's the equal sign, okay? That looks terrible. Here's the equal sign. So meaning that I have to focus here on the right side, and I can see that D is not isolated. Why is it not isolated? Because we're adding 12 to it. So how to get rid of addition? I'm going to subtract 12. So 12 plus D minus 12, this cancels out. D is now by itself. All right. However, whatever I do to one side, I must do to the other. So I must subtract 12 from -7. Now I'm going to do this here on the side. We have -7, and I'll use a different color. We have -7 minus 12. Now, whenever you're subtracting, guys, when in doubt, don't do it as a subtraction problem. Let us change it to an addition problem. And lucky for us, we know how to do that. We can apply KCC. Again, I am not changing the problem. I'm just changing my perspective. All right, so we're going to keep the -7, change the subtraction to addition, and then change the 12 to a -12. So here, ladies and gentlemen, I can see that I am combining 7 negatives with 12 negatives. They are both going in the same direction. They are helping each other out. So just add them together and they're going to remain negative. So negative 12 plus negative 7 or negative 7 plus negative 12 will give us negative 19. Negative 19. So D has to be negative 19. Let us see if that makes sense. If I try to combine 12 positives with 19 negatives, since I am combining them, but they have different signs, I'm going to subtract them. We have more negatives, so 19 minus 12 is indeed 7 negatives. So yes, negative 19 would be the answer. As you can see, guys, I'm just following the same process every time. I'm isolating the variable how using the opposite operation, and whatever I do to one side, I do to the other. Here, this one may seem confusing, but again, t over negative 3, which simply means t divided by negative 3 is equal to 7/8. All right, the variable is here on the left side. How do I isolate? How do I get rid of dividing by negative 3? I don't even need to worry about it. Just do the opposite, multiply by negative 3. All right, that cancels out. So t is going to be left by itself. However, whatever I do to one side, I must do to the other side. I must multiply the side by negative 3, which is negative 3 over 1. We know how to multiply fractions. To multiply fractions, ladies and gentlemen, you just go numerator times numerator, denominator times denominator. 7 times negative 3. So if I do the Fox, I can see that my answer is going to be negative because I have a positive 7 times a negative 3. So it's going to be negative 21 over 8 times 1, which is 8. All right, so ladies and gentlemen, my answer is going to remain negative, but let's just change this into a mixed number. So 21 divided by 8, 8 goes into 21 twice, because 8 times 2 is 16. And 16 to 21, 11, so 8 to 11 would be 5. So the answer would be negative 2 and 5/8. Again, it's more of, do you know how to multiply fractions? Do you know how to divide fractions? Because as far as the process, it remains exactly the same. We isolate variables, how using the opposite operation, and whatever it is that you do to one side, you must do to the other. Let's just do one more together, because as you can see, it's the same process over and over again. Number 6, we're multiplying by 5.4, so just divide both sides by 5.4. Remember, we don't like decimals on the outside. Have fun with that. Number 7, since we're subtracting by 2.9, we're gonna add both sides by 2.9. I mean 2, so not 2.9, 2 over 9. However, make sure that you have a common denominator, ladies and gentlemen. Otherwise, you cannot add or subtract fractions. Number 8, we're adding 3 to the variable. The opposite of adding 3 is to subtract 3. So 1 minus 3. Now that will give you a negative number. So have fun with that. Let's do question 9. Question 9. Question 9, and that'll be the last one that I do with y'all today. We need to isolate the variable. So B is right here. So the opposite of dividing by negative 5 is to multiply by negative 5. All right. Whatever I do to one side, I do to the other. So I must multiply this by negative 5. So B will be whatever 65 times negative 5 is. Now, since they have different signs, my answer is going to be negative. So just do 65 times 5. 5 times 65 times 5 is 25. 5 times 6 is 30. Plus 2 is 32. So the answer has to be negative 325. Ladies and gentlemen, it is that simple. Anyways, I hope that you found this review helpful, and that you find yourself ready for your quiz. And with that in mind, ladies and gentlemen, I will see you next time.